Today we're going to talk about the Pythagorean Theorem. Most of you have already seen this at one point or another, so hopefully this is a lot of review. As we all know, the Pythagorean Theorem is a squared plus b squared equals c squared, where c has to be the longest side, which is the side across from the right angle. So let's look at the first example together. We need to find x. In this problem, x is your c. It is across from the right angle. It is your hypotenuse. So, if we want to solve this, we would do 8 squared plus 6 squared equals x squared. You could interchange the 8 and 6, it doesn't matter. So we know that 8 squared is 64 plus 36, and that equals x squared. If we add those together, 100 equals x squared, so x is simply 10. Done. I want you to take a minute, push pause on the video, and try example 2 and 3 on your own. Pay attention to which side x is in your triangle. So push pause now and try those. Hopefully when you solved example 2, you got x equals 4. Okay, it is not the hypotenuse, so we could say 3 squared plus x squared equals 5 squared, which is 25. Sorry. When you solve that, x squared is 16, so x is 4. Over here, hopefully you got x to be, well, x squared was the square root of 52. I don't want the decimal answer here, so we need to simplify this radical. So if we simplify it, we get 4 and 13, 2 and 2. Pair of 2's, so x is 2 root 13. Okay? In this case, x was the hypotenuse, like I said, so it would be 4 squared plus 36, or 6 squared, which is 36. Okay, let's look at the next slide together. A 16-foot ladder rests against the side of the house. The base of the ladder is 4 feet away. Approximately how high above the ground is the top of the ladder? I'm going to draw a picture. So I have my building here. If I could spell. I have my ladder. Think about how ladders go. They go at a diagonal. You don't place it right up against the house. Okay, the ladder itself is 16 feet, so let's label that. The base of the ladder, so right here, is 4 feet away from the building. So this is 4. We want to know how high above the ground is the top of the ladder. Let's call that x. So from here, Pythagorean Theorem, x squared plus 4 squared equals 16 squared. Now, it doesn't matter if you do 4 squared plus x squared, same thing. But the 16 is your hypotenuse. That is your longest side. So that has to be c. Now, in this case, if you look at your answer choices, they don't have it as a radical. They found the decimal. So if we solve x squared plus 16 equals 256. So subtract the 16 over x squared equals 240. Square root both sides, and you get the decimal approximately 15.5. That one they did leave as decimal form, and I'd always be clear on what I want from that. Okay, I want you to take a second and answer these two questions. Please push pause and try these two. Okay, hopefully you set up your picture with your building and your ladder. Okay, the top rests against the wall 23 feet above the ground. The base is 6 feet away from the wall. And this time we want the length of the ladder. Remember which part is the actual ladder. So if we solve this, 6 squared plus 23 squared equals x squared. Once again, I'm okay with the decimal here. So you should solve and get x to be 23.8 feet. The second question, the Pythagorean Theorem is only true for what type of triangles? Right triangles. You can only use it when you know you have a right triangle. Okay, let's go to the next example. It says find the area. So remember, area of a triangle is 1/2 base times height. We want the area of the isosceles triangle with side lengths 10 meters, 13 meters, and 13 meters. So let's draw this picture. Miss G, we only have the base, I need the height. Remember, the height has to come straight up and down. Well, in an isosceles triangle, if we do that, and we make it come straight down at a right angle, we can have two congruent triangles. Now, think about this. If the whole base is 10 in this isosceles triangle and we draw the altitude down, it's going to split this into 5 and 5. This works once again because we have an isosceles triangle. So if we pull out the right-hand side, where this is my height, we have 13 and 5, we can do Pythagorean theorem to find our height. Remember, 13 is your C, so your height squared plus 5 squared equals 13 squared. If we solve that, we should get our height to be 12. Now, we can go back and plug in. We have 1/2. Now, our base, go back to the whole base of 10 times the height we just found. And we should get 25 feet squared. That's our final answer. I want you to push pause, take a minute to try the two examples at the bottom. Now the 30 represents the whole base and the 20 represents the whole base in these two problems. So break them up so you can find your height. Push pause and take a minute to do that. Okay, in this problem, if we break it up, this is 15. Now, in this problem, they were okay with decimals as well. So let's call this our height. So our height squared plus 15 squared equals 18 squared. Our height is going to come out to approximately 9.9. From here, I'm going to swing over here, 1/2 the whole base of 30 times our height of 9.9. We should get approximately, depending on how you rounded that 9.9, 148.5 feet squared. Over here, split this up into 10. We need to find our height. Height squared plus 10 squared equals 26 squared. Hopefully you got for your height 24. So area, 1/2 the whole base times the height, we should get 240 meters squared. Okay. On the next slide, I don't know if you've ever heard of Pythagorean triples, but they're a set of integers. The key word here is integers, so they have to be whole numbers pretty much, that satisfy the Pythagorean theorem. The most common one is the 3, 4, 5. That always works in a right triangle. If you have your sides 3, 4, this side has to be 5. Okay? Across the bottom here are other Pythagorean triples that are common. So if you ever see a triangle, for example, like this, you can say, without doing the Pythagorean theorem, oh, this has to be 3. Okay? By all means, you can still do the Pythagorean theorem and find that. But these are common Pythagorean triples. Okay, let's go to the next slide. The converse of the Pythagorean theorem says, if the square of the length of the longest side is equal to the sum of the squares of the other two, then it's a right triangle. It's just basically the backwards of the Pythagorean theorem. So if indeed c squared does equal a squared plus b squared, or a squared plus b squared does equal c squared, then you know that you have a right triangle. So let's look at this first example here together. Now remember, c always has to be your longest side. Say you look at this and you're like, well, I don't know if 3 root 34 is indeed my longest side. Throw 3 square root of 34 in your calculator, and you can see that this is approximately 17.5, and it is the longest side. So, let's check. Is 9 squared plus 15 squared equal, and I put a question mark here because we're not sure yet, does that equal 3 root 34 squared? Now, be careful with squaring that 3 square root of 34. We know 81, so 9 squared, 81 plus 225 comes out to 306. This, I would throw this in your calculator. Throw in 3 square root of 34 and then square it. It also comes out to 306. So yes, indeed, this is a right triangle. So even though it wasn't marked, now we can say, oh, we know it is. Now, let's look at the second example together. This is my longest side. So is 22 see, 22 squared plus 14 squared. Throw that in our calculator and it is 680. However, 26 squared is 676. So they are not equal, so this is not a right triangle. Okay. Let's go to the next slide. Now, notice we have the Pythagorean theorem written slightly backwards, and there's a reason for that. If you do the Pythagorean theorem and you get that c squared is less than a squared plus b squared, that means that the triangle is acute. If c squared comes out greater, that means it is obtuse. Okay, so let's try some examples. Can segments with lengths of 4.3, 5.2, and 6.1 feet form a triangle? So go back to last chapter. Do they form a triangle? So if we add these together, we get 9.5. If we subtract them, we get 0.9. Is 6.1 between there? Yes. So it is a triangle. So yes, we have a triangle. Now, if so, is it going to be right, acute, right, or obtuse? So let's see. 4.3 squared plus 5.2 squared. Now, they're my A's and B's, because they're my shorter two. I'm going to write those on the right-hand side this time, and I'm going to do c squared over here. And I leave this part blank because we don't know if they're equal, greater, or less. So let's do that math. 6.1 squared is 37.21 approximately. If you add your right-hand side, you get approximately 37.21. So, my bad, I wrote that backwards. You get 45.53. So this is less than that. So if it's less, we have an acute triangle. Okay? I want you to push pause and try the bottom three at this time. Okay, let's take a look. In 15, they do indeed form a triangle because their difference is 1, their sum is 21, and 14 is between them. Now, let's see. Is 14 squared greater, less than, or equal than 10 squared plus 11 squared? If we do that math, we get 196 and 221. So this is less. Once again, we have an acute. Come over here. Take their difference and their sum. If you figure out the decimal of this, it's approximately 18.02. That does fall in between, so it is indeed a triangle. Now let's see. Is 5 root 13 squared, and I would use your calculator for this, greater, less, or equal to 10 squared plus 15 squared? If we do that math out, we get 325 and 325. So they're equal, so that means we have a right triangle. And the last one, take their difference and their sum. This as a decimal is 39.3 approximately. It's between, so it is a triangle. Now let's see. 6 root 43 squared. We want to know, is that greater, less than, or equal to 24 squared plus 30 squared? Running out of room, sorry. So 643 is 1,548, and the right-hand side is 1,476. So it's greater than, so it is obtuse. Okay? Please make sure you have all of this written down in your notes, okay? And I will see you guys in class.